You know, when you think about computer code and algorithms, you probably think of Silicon Valley, right? Modern stuff. But what if I told you that the blueprint, the fundamental logic, was actually written 2,500 years ago? Not for a computer, but for language itself. Today, we are diving deep into the work of Pāṇini, an ancient Indian scholar who is rightfully called the father of linguistics, and whose system for grammar operated with a logic so advanced, it's just stunning. Now, take a look at this. This quote really frames what we're talking about today. The idea that Sanskrit isn't just a language, it's a coding language, and its grammar is an algorithm. That's a bold claim, and it forces us to look at the ancient world through a completely different lens, one that feels incredibly modern. So that's the big question we're tackling. Is it possible that the core principles that power our digital world, we're talking logic, algorithms, functions, efficiency, could have their roots in a text about grammar from over 2 millennia ago? I know, it sounds a little like science fiction, but you'll see the evidence is absolutely fascinating. To even begin to answer that, we have to start with the man himself. So who was this genius? Who created this, well, revolutionary system? Let's meet Pāṇini. In the world of linguistics, Pāṇini isn't just some name in a textbook. He is an absolute giant. He's not just another grammarian. Many consider him the very first true scientific one. His work wasn't just describing a language. It was a complete, systematic machine for understanding its structure. That's why he's earned the title Father of Linguistics, especially from modern scholars who were just stunned when they first discovered his work. Now, Pāṇini came from a place that was a real crossroads of the ancient world. Salutura, in the Gandhara region, was a major hub for learning, for trade, for culture. This area, which is in modern-day Pakistan, was a total melting pot of ideas. And that might be one reason his thinking was so unique and systematic. He really was a product of a vibrant intellectual world. You know, it's funny, for someone so important, we're not even 100% sure exactly when he lived. It's a huge debate among scholars. Some say he was earlier, maybe the 6th or 5th century BCE, because the type of Sanskrit he's describing is super close to the ancient Vedic texts. But others argue for a later date, around the 4th century BCE, based on things you can actually point to, like his mention of a specific coin, the nishka. The mystery just kind of adds to his legend, doesn't it? And of course, for a genius of this magnitude, there has to be a pretty epic origin story, right? The legend says Pāṇini wasn't just a brilliant guy who sat down and figured all this out. No, he was divinely inspired. The story goes that the god Shiva, in his cosmic dance, played his drum, the damuru, and from it came 14 fundamental sound groups. Pāṇini heard them, understood their hidden structure, and used them as the very foundation for his entire system. These are the famous Shiva Sutras, and as we're about to see, they are the absolute key to his code. Okay, so that brings us to his masterpiece, the Aṣṭādhyāyī. And let's be clear, this is not just some old grammar book. It is one of the single greatest intellectual achievements in human history, period. So let's try to deconstruct this thing. 3,959, that's it. That is the total number of rules, or sutras, in the Aṣṭādhyāyī. Now, a sutra is like a tiny, super condensed rule, almost like a line of code. Pāṇini's genius was to describe the entirety of the complex Sanskrit language in fewer than 4,000 of these incredibly dense statements. The whole thing was designed to be memorized and can be recited out loud in just a couple of hours. It's efficiency on a whole other level. And here is the really mind-blowing part. The Aṣṭādhyāyī isn't just a rule book telling you what's right or wrong. It's a generative system. It's a kind of language machine. You can feed it a basic root word and some conditions, and its rules will automatically churn out a perfectly formed, grammatically correct word or sentence. Now, to build a machine like that, Pāṇini had to invent his own meta-language. Basically, a language about language, with its own logic, its own terms, just like a programming language gives instructions to a computer. And this is the engine room of that machine. These are the 14 Maheshwar Sutras, the sounds Shiva supposedly revealed. Just look at them for a second. They're not in any kind of alphabetical order you'd recognize. They're not grouped by how they sound in your mouth. They are organized for one thing and one thing only: maximum algorithmic efficiency. Pāṇini created a custom-built phonetic alphabet designed for data compression. So how did he achieve that compression? With an incredible technique called pratyahara. The easiest way to think of it is like a shortcut or a macro on your computer.
See, the last letter of each of those sutras, that's a special marker called an anubandh. It's not actually a sound you pronounce, it's a piece of code. A pratyahara combines a real sound with one of those markers to refer to a whole group of sounds all at once. Let's actually see it in action. It's way easier than it sounds. We're going to build the pratyahara called ach. Okay, first, you grab the letter A from that very first sutra. Simple enough. Then you go down to the fourth sutra and find the special marker cha. By just putting them together to make the word ach, Panini created a single term that instantly means every single vowel in the Sanskrit language. Instead of listing them all out every time, he can just say ach. It's an absolutely brilliant compression tool.
And this is where it all just clicks, and you see the direct line to modern coding. It's almost spooky. Painini's system has concepts that act just like programming keywords. These are terms with fixed definitions. It's got operators, which are suffixes that modify variables, like nouns. The rules, the sutras themselves, they work just like functions. They take an input and produce a predictable output. He even has a concept like a software library, where rules from one section are just assumed to carry over to the next, so you don't have to repeat code. This wasn't just grammar, it was a computational system for language. So, a system this brilliant, what happened to it? What was its impact? Well, Panini's work didn't just fade away. It fundamentally shaped how we study language for the next 2,500 years, first in India, and then, eventually, the entire world. Well, when Western scholars finally got their hands on Panini's work in the 19th century, they were floored. Fritz Stahl, a major Sanskrit scholar, didn't hold back. He flat out called Panini the greatest linguist of antiquity, recognizing that this was a mind working with a level of scientific rigor that was just unheard of in the ancient world. And that wasn't just a one-off opinion. You see it echoed by so many others. Renz Bod says it plainly, the scientific study of language doesn't start in ancient Greece with Plato or Aristotle. It starts with Pāṇini in India. I mean, that completely reframes the entire history of the field.
Back in India, his impact was immediate and, well, total. The Aṣṭādhyāyī was so perfect, so complete, that it essentially became the standard for the language. It created what we now call classical Sanskrit, the language of epic literature, deep philosophy, and science for the next 2,000 years. In a very real way, his grammar almost froze the language in its most elegant form, protecting it from changing over time.
And that influence, eventually, made its way west, where it shaped modern thinking in profound ways. Take Ferdinand de Saussure, the father of modern structural linguistics. He was a Sanskrit professor. It was through people like him that Panini's core idea that language is a formal system of interconnected rules helped shape the entire direction of linguistics in the 20th century.
Today, those connections are not just analogies anymore. They're direct comparisons. Computer scientists and linguists see his generative system as a precursor to the Turing machine. That's the abstract model that is the foundation for all modern computers. And his system of using markers and rewrite rules, it's directly comparable to something called Backus-Naur form, or BNF, which is a notation used to design the syntax of pretty much every major programming language you've ever heard of.
So, okay, this is an incredible story from ancient history. But beyond that, why does Panini's work still matter so much today? What's the real takeaway for us? All right, let's just boil it down. What's Panini's ultimate legacy? First, he proved that language, this messy human thing, could be described by a complete, logical, formal system. Second, he did it with a profoundly algorithmic mind, inventing concepts we now see as fundamental to computer science. Third, that system was so powerful it literally became the architect of classical Sanskrit for thousands of years. Fourth, for all these reasons, he is, without a doubt, the true father of linguistics. And finally, his methods are more relevant today than ever because they prefigure the very ideas at the heart of things like AI and computational linguistics. And that leaves us with one last, kind of mind-bending thought. Panini's language machine reveals a level of scientific and logical thinking in the ancient world that we're really only just now beginning to fully appreciate. And it just makes you wonder, if a system for grammar could hold this much hidden logic, what other secrets, what other kinds of algorithms are just waiting to be discovered and decoded in other fields of ancient knowledge?